Hey guys, welcome to 2.3 differentiation rules for products, quotients, secants, and tangents. In this video, I'm going to be showing you guys how to take the derivative for products only, and then the next video I'll do quotients and the secants and tangents together. So let's go ahead and talk about derivative. We know that derivative means change. Derivative means slope. Okay? We've already found an easy way how to take derivatives now that we learned the power rule. So this is a refresher right here. The power rule says if I take the derivative of x to the n, that is nx to the n minus 1. Example, 3x to the fifth. Well, the derivative of 3x to the fifth is 5 times 3x to the fourth. Notice I dropped down the power of 5 and I took away the power of 5 from the exponent, and now it's 15x to the fourth. In this video, we're going to be talking about how to take derivatives of functions that are being multiplied together. Let me give you an example. 2x times cosine x. Notice that these two are functions being multiplied. Now, one big misconception that I used to see last year and the year before that was that my students would take the derivative of each term and then multiply it together. For example, the derivative of 2x is 2, and the derivative of cosine x was negative sine x. And then they would answer negative 2 sine x, and that is incorrect. The derivative of products is not the product of the derivatives. So that's one big misconception. You don't do that. There's a special rule for that, and I'm going to go and discuss that right now. The product rule. The product rule states that anytime you take the derivative of two functions being multiplied, you take here's the rule. You keep the first term, the first function. You multiply it by the derivative of the second function plus the second function, or the original function, times the derivative of the first function. So the product rule just says take the first function, multiply it by the derivative of the second, plus the second, multiply it by the derivative of the first. Now, let me go ahead and state the product rule a little bit more differently. Anytime, this is very common in a lot of textbooks. We can say that u is f of x and v is g of x. Now, with that statement, I can rewrite the product rule much more easier to see and read. If I want to take the derivative of u times v, and notice u and v are not variables, they're functions now. Okay? So the derivative of u times v would be the u v prime plus v u prime. Now, that is the rule that we're going to be using from now on. So make sure you put that in your notes. U times v prime plus v times u prime. When I was in high school, I used to just memorize it pretty much like the way the product rule would state. I would always just tell myself the first times the derivative of the second plus the second times the derivative of the first. Now, if you notice these two pairs, this pair has one original and one derivative, and the second pair has the complete opposite. So that's another way of remembering the product rule, is that your pairs will have one derivative and one original, and then the other pair would have the opposite. So let's go ahead and use the product rule in the first example. In the first example, we have y is equal to 3x minus 2x squared times 5 plus 4x. So let's do this without the product rule. And let's see what kind of answer we can get, because this is a simple FOIL, and we can do FOIL, and we can take the derivative of what we FOILed. So when we FOIL, we get 15x plus 12x squared, negative 10x squared, and negative 8x cubed. And then cleaning this up a little bit, it's 15x plus 2x squared minus 8x cubed. And finally, if I want to do the product rule, let me move this up a little bit. Well, not the product rule. If I want to take the derivative now, it's going to be 15 plus 4x and then minus 24x squared. Now let's do this with the product rule. And I'm not saying the product rule is easier, but it definitely will be in the next example. So let's do this with the rule. The rule says from the very beginning, we're going to take, let me clean this up a little bit. We're going to take the u and the v and use the product rule of u times v. So let's go ahead and see what u times v is. U times v, the derivative of u times v is uv prime plus vu prime. So it's going to be u v prime. What's the derivative of v? Well, it's simply 4 plus v, now it's the original v, times the derivative of u prime, and that is 3 minus 4x. Okay, so like I said, not always will the product rule be much easier, but it is the sure way of finding derivatives of products. So let's distribute. So it's going to be 12x minus 8x squared plus, now we have another FOIL, so it's 15 minus 20x plus 12x minus 16x squared. And if I combine like terms, I have a 12, another 12, and a negative 20. 12, 12, negative 20 will give me a 4x. And then I have a, what else do I have? Negative 8x squared and a negative 24x, negative 16x squared, which gives me a total of negative 24x squared. And then I have my 15. And I see that my derivatives are the same, just in different order. Example number 2, and we're done with this video. Example number 2 says, if y is 2x cosine minus 2 sine x, find y prime. Okay, so let's break this down. So let me go ahead and clean this up just above this, since we already have the answer. Let me go ahead and label this. This is my u, and then this is my v. Notice that I'm separating 2x and cosine x. And this is just simply my derivative. I'm just going to call this, I don't know, f of x. Okay? I have a product minus a regular function. So let's take the derivative. U times v prime, which is negative sine x, plus the v times the u prime. What is the derivative of 2x? It's 2. So let me just go very slow. All I did was take the derivative of this product, and I got this. Let me continue with the rest of the function. Minus the derivative of 2 sine x is 2 cosine x. Let's go ahead and clean this up even further. So it's, let me bring the negative to the front, because that negative does not mean minus, it just means the negative of sine. So it's going to be negative 2x sine x plus, let me bring this 2 to the front, 2 cosine x minus 2 cosine x. And I see that I have the same thing, so my derivative is simply negative 2 sine x, I'm sorry, negative 2x sine x.